All right, so we're continuing our topic of dividing polynomials today, but today we're going to look at a different method. Yesterday we used long division. Today we're using what is known as synthetic division. But here's the thing about synthetic division. We are only able to use it when we're dividing by a linear binomial. Okay? Let me make sure you understand what those two terms mean. Linear, binomial. Linear means you have a variable to the first power, like x. Binomial, of course, means two terms. So only in that situation can you use synthetic division. Long division, you have more flexibility. You can pretty much divide anything you want, but synthetic division isn't that way. So let me show you, and this is the same note example 1a that we did yesterday, but let's see how we can arrive at the same answer using a different method. So the first thing I want to point out is so important. If you don't get this, you're going to miss these problems, so pay close attention to what I'm about to say. I don't want to go through the whole synthetic division definition because it's a lot of mathese. Let's just break it down into the most important part of the definition. The definition of synthetic division says that you're dividing by a binomial that is x minus some number, n. Okay? That's always true. You're dividing by a binomial that always looks like this, x minus something called n. Okay, so if I take this part of the definition and I compare to what this problem says, what would you say n is equal to in my red example? 3. Okay, a lot of people will miss this because they look inside the parentheses and they think they're supposed to use -3. So this is another one of those cases where you really have to think opposite of the way the problem looks. The number that we're going to use in our division is actually +3. And again, that goes back to what the definition says. Okay, you can just compare. N has to be 3. So now that we've established that, that's a very important first step, because if you miss that, again, you're going to miss the whole problem. We're going to set up synthetic division, and it looks like this. That n number that we've already figured up is 3. I'm going to put it in what I just refer to this as the house. I'm putting 3, it's like a half a box. And then to the right of that number, that n number, we're going to write just the coefficients and the constant of what we're dividing into. So one of the things that people like about synthetic division is you don't use any variables, at least in the division part. Okay, and now I'm going to intentionally leave a space under these numbers because eventually we will have numbers underneath, and I'm going to draw a line, leaving room to write some things. And now synthetic division starts. Here's how it begins. You always, whatever this first number is, you just bring it down below the line. Numbers below the line multiply times the number in the house. 1 times 3 is 3. So notice I'm putting that product over in the next column. Here's another thing that a lot of people like about synthetic division. Unlike long division, where you're always having to subtract, with synthetic division you always add. So these numbers in this column, I'm going to add. 7 plus 3 is 10. And now it's just a lot of repetition. The number below the line, you multiply times the number in the house. 10 times 3 is 30. And you always add. Okay, now let's interpret these numbers that are below the line. This is always true. This last number, this number to the far right, is always the remainder. As we move to the left, this next number will always be the constant of our answer. That means a number without a variable. As we move left again, this is a coefficient for the linear term. So linear means, in this case, x to the first. So that's the coefficient for the linear term. So putting this all together, you don't stop here. Your answer is really going to look like it did last night. You're just going to get there a different way. So my final answer here is just going to be x for the 1x plus 10 with no remainder. And if you have your notes from yesterday, you see that. We got that same answer yesterday, but we used long division to get it. And that is synthetic division. Any questions so far? We'll do a couple of easy examples, and then we'll up the intensity just a little bit. Okay, so big question here. What is that n number that I'm going to put in the house? Casey? 1. Good answer. Most people miss this right off the bat because they use the wrong number. Okay, to the right of 1, I'm going to write the coefficient for x squared. I'm going to write the coefficient for x, and then I'm going to write the constant. I'm going to leave a space, draw a line, and now the process begins. You always start by bringing this first number down below the line. So another way of looking at it is there will never be anything here. This is always empty space underneath that first number, always. Nothing ever there. Multiply. 1 times 1, add. Multiply. Negative 12 times 1, add. Now interpret the answer. This is always the remainder. This is a constant. This is a linear coefficient. So my answer is x minus 12. Any questions so far? All right, let's do another one. Okay, Sarah, what is the number that I'm going to put in the house? Good job. Negative 3. To the right of negative 3, Devin, I'm going to write what? Okay. We didn't jump any terms. 3, 2, 1, constant. Very good. I'm going to leave a space. And let's see, Hannah, I don't know if you can see that real well. What am I going to put here where I'm circling? Good. And Heather, what am I going to put here where I'm circling? Good. Maggie, what about here? Good. Okay. Let's see. Colin, what about here? Good. Noah, what about here? Good. Madeline, what about here?
Honestly, I don't have to say division. I don't know.
5 times negative 3. Very good. All right. I'll just get a show of hand or first hand up. Anybody want to volunteer to give me the final answer, the polynomial answer? So you never stop here. The answer should be a polynomial. So, Sarah.
Is it 2x squared minus 3x plus 1?
Very good. Now here's something that you can check. This should always be true. When you get your answer, it should be 1 degree less than what you divided into. Okay? Do you notice how my answer is 2nd degree, but I divided into 3rd degree? We divided into 2nd degree, answer is 1st degree. That should always be true. Okay. Let's try this one. So let me get Abby to give me the number that would go in the house. Nice. Okay, Abby, what will be written to the right? Negative 8. Now, I tricked Abby a little bit. We talked about this yesterday with the assignment. Do you notice how we went from exponent 4, exponent 3? We jumped over the exponent 2. So what should I put in that place for exponent 2? Yeah, we're going to have to put in a filler, a spacer, because we jumped that exponent 2. Then we can go to 12, and then we can go to negative 14. Okay, so remember that's the same idea that we talked about with long division. There may be times where we have to put in a 0 to fill in a space. Okay, Kate, what's going to go here? Oh, you always just bring this first number down. 6, okay. So let's see. Madeline, what goes here? 12, very good. And Sarah, below 12? Good. Casey, below the 0? Good. Noah, below the 8? Good. Heather, below the 12? Good. Hannah, below the 16? Good. Colin, below the negative 14? Good. And then below that, let's see, Sarah, below the 56? 42. Okay. Kate. Okay. All right, so give me the polynomial answer.
6x cubed plus 4x squared plus 8x plus 28 plus 42 over b minus 2.
Nice. Yeah, we're going to show our remainder just like you did on last night's homework with long division. Oh, yeah, it should be B. I do that sometimes too. Yeah, our problem was in B, so we should keep our answer in B. You had the right idea though. Sorry about that. B, 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 B. Any questions? Do you like synthetic division? Me too. But you're limited again. You can't use it for everything. That's the problem. What's the difference in this problem and the previous ones? Yeah, that complicates things just a hair, just a little bit. So if you recognize that the number in front of x, the coefficient of x, is something other than 2, you're going to need to do a little bit of work before you get right into synthetic division. Just a little bit. Okay? So the number in front of x is 2. So what I'm going to do is I'm going to go across this entire problem and I'm going to divide each term by 2. I'm not saying you have to actually show this, but I'm being doing a little bit overkill just so you'll know what to do. If this had been 4x plus 1, I would be dividing everything by 4. Whatever's in front of x, you're going to divide by it. And now let's see what the result would be. This is going to be 4x to the 4th. What should we put in here? 0. We jumped over the cubic term. Now we're down to the squared. 2x squared. The linear term now is just going to be 1/2 x plus 2. And that's all going to be divided by x plus 1/2. So let me just pause there for a second and see if there's anything that you do not understand about what just happened. You understand how we got each of these blue terms? Okay, now we can start synthetic division. So Hannah, what's going to go in the house? Good. Let's see. Colin, give me the numbers that I will write to the right of negative 1/2.
4, 0, -2, 1/2, and 2.
Good. Okay. Let's leave a space, draw a line. Noah, what's going to go here underneath the line beneath 4? Good. And Devin, what about under the 0? Four times negative 1/2. -2. Good. Maggie underneath -2. Good. Casey underneath this -2. Okay. Kate underneath the 1. Good. Madeline here underneath the 1/2. Would it be -1 times negative 1/2? Negative times negative. It'd be positive. Okay. And then let's go over to Heather. What about underneath the line, underneath 1/2? 1. Good. And can you tell me here, Zach, can you tell me underneath the 2? 1 times negative 1/2. Good. And then finally, we should get 3/2. Everybody understand that? Yeah, because in the end, we're going to have a complex fraction like you did last night that you're going to have to simplify. So you might as well leave it as a improper fraction. So we started off at cubic, so this should be, quartic, this should be cubic. That means 3rd degree. So let's see, remainder, constant, linear, quadratic, cubic. 4x cubed minus 2x squared minus 1x plus 1 plus, now we ran into this sum last night, 3/2 divided by x plus 1/2. Well, you should never ever leave a complex fraction answer. So, how did we deal with this? I know you've done it in the past. How did we deal with it last night? Dividing by x plus 1/2 is the same thing as multiplying by what? Which is 1 over x plus 1/2. Dividing by a number is like multiplying by its reciprocal. So what is 3 times 1? That's the numerator. 3 over, what will the denominator be? If you distribute 2 to both of these. Sarah, can you do that? All right, so my remainder, instead of showing it like this, 3/2 over x plus 1/2, I'm going to show it as 3 over 2x plus 1. So I just need to make sure you understand how we got that. So I'm going to erase this complex fraction and put it in proper form. Any questions? We're going to do one more of these where the number in front of x is not 1, and then that will conclude the notes. Any questions? All right, let's try it. So, all the way across this problem, since this coefficient for y, the linear term, is 4, I'm just going to go and divide by 4 all the way across every term, including the binomial divisor. Let's see what we get. This is going to be 2y to the 5th. 2/4 is 1/2. y to the fourth. There is no cubic term, so I need to put in a spacer, a 0 term. This is going to be 16 over 4, which is 4, y squared. There is no linear term. There's no y to the first. I need another spacer. And then finally, the constant is going to be 1. And that's all going to be divided by y minus 1/4. Okay, so the number that goes in the house. What goes in the house? Madeline. Very good. Positive 1/4. So Kate, tell me what I'm going to write to the right of this number in the house.
2, -0, 4, 0.
You mean -4? Okay. And it always starts, the first move is to always bring this first number down. Remember, you'll never have anything underneath this first number. It's blank space. So let me get Maggie underneath -1/2. 2 times a fourth, positive 1/2. Okay, and Heather underneath positive 1/2. 0. Hannah underneath this 0 above the line. Okay, and below the line. Good. Okay, Abby underneath -4. 0. And Casey underneath the 0. Good. Noah underneath this 0. Good. And let's see, Zach underneath the -1. Good. Colin underneath the 1. And let's see, I'll go back to Devin. 3/4. All right, let's put it in a polynomial answer. So this is remainder, constant, linear coefficient. This would be the quadratic coefficient, so we don't have one. This would be the cubic coefficient. We don't have a cubic term. So this is the quartic. That means 4th degree. So 2y to the 4th minus 4y minus 1. Now, let's see if we can simplify. We're going to do 3/4 over y minus 1/4. Well, dividing by 1/4 is the same thing as multiplying by 1 over. Okay? So dividing by y minus 1/4 is really this. Let's just come over here and show this. Okay, that's how we're going to get our final remainder. So what is the numerator of the remainder? Sarah. Okay, I'm going to erase this ugly complex fraction. And we're going to change it. 3 times 1 is 3. Colin, can you tell me the denominator of the remainder?
4y minus 1.
Very good. Very good. There's your final answer. Any questions? All right. This is the end of your notes for lesson 4.3, part 2. And let me know if there's anything I can do to help you.